Yes,
You're
sir.
audible.
Very good.
Yes, sir.
So we'll see about what is an IP address and small points of IPv4 and IPv6 and IPv4 address and classes up to here. Okay, this part only we'll see today. So tomorrow we'll see the remaining part. Okay, those who are available in that time, so join. Okay, if you are having voice and accent or maybe version test when during the technical session, okay, so you can join later after test is completed. You can join. Okay, anyway, we have a recording, so definitely you can go through recording and notes in case of you are missing the class due to your test or any other things. Okay, but class will be continued tomorrow. Again, I will share what are the timing and all. Okay, so depends upon tomorrow. IP address mostly like this time only, like 10 o'clock. So today we start almost like 10 o'clock, right? So like a 10 of 9:30 to 10 in between only will start. 9:30. Generally 9:30 is the best time. Okay. Next. So guys, out of 5 points, what are the 5 points? It is first one is NIC, next one is media. Okay. And third one is networking device. So up to now, we created a network. Up to now, we created a network. Right? So different devices, different way of connectivities, different cables we are using, we are connect, right? Now we want to communicate. To communicate in a both side of systems, need an IP addresses. What is this IP address? Is a logical address. So compulsory devices must have a logical address. The physical address is MAC address. The logical address is IP address. What we are using is in TCP IP. So is a IP address we are using. So what is this IP address? It's uniquely identify a device in network. In a network, so there is a devices. Each device you want to identify uniquely in that network, logical way. You want to identify them in a logical way. So what we are using is an IP address. Guys, what is this logical address? Why there is a IP address? Why there is a MAC address? Thing is, MAC addresses are unique addresses. It means not in the one network. It is always in universally. It is unique address. So my laptop, my NICs, that MAC address not repeated in this world. This won't be repeated in this world. It's more unique. So, but why we are using not using a MAC address to communicate? Why we are using IP address to communicate? Thing is, IP address, that a whole network in the worldwide entire network is divided into logical way. We can divide a network into logical way. So within a one group, communication is possible between the networks. Within the network, we can communicate. Between the networks, you want to communicate. Like that, we can control the connectivity and communication between the devices and networks also. Okay. So devices and networks also. Otherwise, what happened? No security, nothing. All are in the same network type only. Okay. So if you are trying to communicate with the only single MAC address kind of stuff, it's unique address. Why we need an IP address? But there is no boundaries, no logical separations. Okay. Only physical separation possible, but still logically we can't separate it. Networks of network, whole all networks are connected. So now it is no logical separations. Anybody can communicate it to anyone with or without knowing the destination, right? It becomes chaos. So it's not a right point. So we have to divide and control into the network. Okay. So that's logical way. So what is IP address? Is a logical address. This IP address uniquely identify device in that network. Okay, these IP addresses we can assign are configured manually or automatically. So the IP address what I have showed, that is ncpa.cpl. Okay, ncpa.cpl. So we can get an IP address automatically from DHCP server, or you can configure an IP address manually as yourself. You can configure it. Okay. So, and there is a DHCP server. So now again, you got this DHCP server. The DHCP server assign an IP address to our client devices automatically. So it means you don't need to worry about what network, what IP, what kind of address it is. You don't need to from DHCP server. The IP address will be assigned to your devices. Okay. Okay. So what is the DHCP server is doing? It assigns an IP address to the client devices automatically. So what you have to do in your system, you have to select automatic options in your laptop, your mobile phone, your smart TVs, your desktops. So if it is a laptop or a desktop, what you have to select it in the properties. Okay, double click on your adapter properties, then select IPv4 properties and select obtained IP address automatically. In certain devices, okay, we use automatic option, automatic configuration. So what happened? That adapter will search for the DHCP server and get an IP address from DHCP server. Okay, so that is a option. So from DHCP server, okay, the DHCP server assign or configure IP address to the client devices automatically. This IP address can be changeable, like you manually can change an IP address, automatically IP address can be changeable. So IP address defines logical network. IP address defines logical network. Okay. So for example, there is 100 devices are connected physically. All are in the same physical network. But you want to make a 20 devices should be communicate each other only between the 20 devices communication. No other devices communicate. How can we divide? Using IP address configuration only. So that's it is. It defines a logical network. Logically, we can define the network. And the point is every device must have an IP address to communicate in the network. Okay. So you want to communicate from my laptop to some destination device, I want to communicate. That should have an IP address. So without IP, you can't communicate. All communications by IP address only. Even last time we have seen, that is, like you want to get to know the google.com IP. Why we should know the google.com IP? Because all communications by IP address only. So no, there is no direct google.com kind of communication it is. You should know its IP address. Okay. So how you'll get an IP address of www.google.com? Again, we send a request to DNS server and DNS server returns IP address of www.google.com to our system. That's our system will send a packet to the google.com with an IP address. Okay. So this is an IP address, guys. What is an IP address? Is a logical address. IP address is a uniquely identified device. Compulsory use this sentence. If you cannot, don't use it. Don't say IP address is unique address. Don't say that is a wrong address. Wrong statement. Okay. IP address is uniquely identified device in a network. So why we are using IP address? IP address use it to identify a device, uniquely identify a device in a network. Simple example, guys. Simple to understand is a IP address is to understand. We have a roll number, right? Yours is a batch number 6. So I assign a roll number like this. Batch number 601. Batch number 602. Okay. 603, 604, 605, 606. So there is a batch number 5 is also there. For them also there is a roll number 501, 502, 503, 504, 505. Okay. So what is this 01, 02, 03, 04, 05? is the individual identities. The 5 represents whole identity, entire batch identity. So fifth batch, okay, 502 and 505, both are belongs to fifth batch. 602, 605, both are belongs to sixth batch. Okay, so these are a 01, 02, 03, 04 are a individual identification, and 6 is entire whole identification. Same way, IP address is also network and host portion wise it is divided. That's it is uniquely identified device in the network. And IP address can be changeable. We can change our IP address. We can change our IP address manually or automatically. DHCP server assign or configure IP address to the client devices automatically. IP address can be changeable or by the manual or automatic. Every device must have an IP address to communicate in the network. IP address defined logical network. All communications by IP address only. And these IP addresses are two versions, IPv4 version and IPv6 version. The IPv4 version of IP address look like this one. So it is, there is a 3 numbers separated by a dot like this. Okay, sorry, there is a 4 numbers. Okay, from 0 to 255, 4 numbers are there between 0 to 255 and separated by dot. So this is how the IPv4 is look like. Okay, like this. And IPv6 is a 128-bit in binary format, and it is represented in hexadecimal format. Okay, of course, writing of IPv6 is little different from based on the IP address. Okay, so this is about your IP address, and here it is some few points about IPv4 and IPv6 differences. Difference wise only, I'm talking. What it is? Okay. I think she's practicing. She forget to mute. Okay. Okay. IP address, we understand, guys, what is IP address, then IPv4 and IPv6. Small differences, then we'll close it. Okay. Few of the differences first. So tomorrow we'll discuss again about IPv4 classes, subnet mask, private, public IP addresses, OSA model, and troubleshooting. Okay. So then we'll see IPv4 and IPv6. IPv4 is 32-bit in binary format. In binary, if you write IPv4, it's a 32-bit number it is. In IPv6, it's a 128-bit in a binary format. Bit and bit means itself it is a binary format. Okay. So there is a 128 bits are in a IPv6 in the binary format. So then if you put a 2 to the power of 32, it means if you start writing an IPv4 addresses from all zeros to all ones, means starting to ending, all IPv4 in a 32-bit format, it is 4.3 billion IPv4 addresses are there. So approximately 4 crore. So 4 billion, 4 billion 294 million 967,296 IPv4 addresses, exact number. And 2 to the power of 128 is a 3.4 billions of IP addresses. Okay, it's called some kind of decillion kind of stuff number is there. It is 3.4 into 10 to the power of 38, 3.4 into 10 to the power of 38. It's a very huge size of IP address. And IPv4 represented in decimal format, IPv6 represented in hexadecimal format. IPv4 So it is an example of IPv4 and example of IPv6. Guys, in IPv4, I said it is represented in decimal format. And this entire 32-bit, this 32-bit is divided into 4 parts. Each part we call it as an octet because it is 32 by 4. Entire 32 is divided into 4. So in case we got a 8. So because of each part is having a 8 bits, that's why we are calling that as an octet. And these octets, these 4 octets, totally we are divided into 4 octets. Each octet is separated by a dot. Okay, that's why you have to read like this. 192 dot, 168 dot, 1 dot, 34. Octet means 8 bits. 2 to the power of 8 is 256. Means each octet range is from 0 to 255. Each octet range is from 0 to 255. Okay. And this structure is like this. There is a 4 octet. The octet name is first octet, second octet, third octet, fourth octet. Like some people use for very easy convenience purpose. So they're used like this. So W, X, Y, Z. Instead of first octet, second octet, third octet, fourth octet, they use like a W part, X part, Y part, Z part like that. Okay. And the starting of IPv4 address is 0.0.0. Starting IP address is start with a 0.0.0 and it is ending with a 255.255.255. From this 0.0.0 to 255.255.255, there is a totally 4.3 billion IP addresses are available. This entire range of IPv4 address again is divided into 5 classes. Already I told guys, why not MAC address? Why IP address? Because IP address divides logically. So that is one of the main purpose of dividing this entire IPv4 address. Instead of using a 0.0.0 like that 1, 2, 3, 4, like instead of using individual ID, we are using to the classes wise. Okay, we're dividing the IP addresses into 5 classes. And these classes also depends upon the first octet or a W portion of IP address. First octet. So this 5 classes division based on the first octet only. So like this, the class A, class B, class C, class D, and class E. The class A is from 0 to 127. It is class B 128 to 191, class C is 192 to 223, class D is 224 to 239, class E is 240 to 255. For example, you see any IP address, check there, they check their first octet. See, it is 134. See, the 134 is in between this range. So this IP address is class B IP address. You see, it's a 156. The first octet is 156 is in between this range. So that is also class B IP address. Take another IP. The first octet is 10. So obviously it is in between this range. It is a class A IP address. This is first octet is 194. So 194 means it is a class C IP address. See, this is 224. First octet is 224. So it is 227. I think it's 227, sorry. So it is a class D IP address. So this is how we are dividing our IP address into the classes. IPv4 into classes. Class A, class B, class C, class D, class C. So detail we can discuss. Okay. So what is why it is showing this 1 to 126? What is this 0.0.0? What is 127.0.0.1? What is unique address? What is multicast address? What is RND addresses? We'll discuss separately. Okay, or we can read it from there. So what is this IPv4, guys? It's a 32-bit 4.3 billions of IP addresses represented in decimal format. This entire 32-bit is divided into 4 parts. It means each part we call it as an octet. So we have a 4 octets separated by dots. Each octet having 8 bits, it's 2 to the power of 8 means 256, means 0 to 255. Each octet size is between 0 to 255 only. This entire first IPv4 address is start with 0.0.0. The last IPv4 address is 255.255.255. This is the total range of IPv4 addresses. And this IPv4 address is further divided into 5 classes: class A, class B, class C, class D, class E, based on the first octet of the IP address. So when you are checking what class of IP address it is, you have to check the first octet and check with this ranges. The class A range is 0 to 127, class B is 128 to 191, class C is 192 to 223, class D is 224 to 239, class E is 240 to 255. Okay, so this is IPv4. Plus some more points are there, but we have to comparing with IPv6. Of course, later few more points with few more points we'll also compare. IPv6 is 128-bit, 2 to the power of 128 is 3.4 billions of IP address. It is 3.4 into 10 to the power of 38. Okay, it is very big than your IPv4 address. In IPv4 and IPv6, IPv4 represent decimal format, IPv6 represented in hexadecimal format. This IPv6 is represented in hexadecimal format. Each hexa number, one single hexa number, represented with the 4 binary bits. Each single hexa number represented with the 4 binary bits. So that's why this is 128 in a size of binary. So it is divided by 4. It is 32 hexa numbers are there. In IPv6 address, there is a totally 32 hexadecimal numbers. These entire 32 hexadecimal numbers are divided into 8 blocks. This entire IPv6 hexa numbers, 32 hexa numbers divided into 8 blocks. Each block is separated by colon. Each block contains 4 hexa numbers. Each block contains 4 hexa numbers. Totally, we have 8 blocks. Each block is separated by colon. Okay, are separated by colon. Next. And in IPv6, we are not divide entire range of IPv6 into the classes. Okay. In IPv6, there is a certain ranges are there, like a global unicast range, link local range, private range, multicast range, anycast range, like a different purpose of communication, different ranges are given. Unicast, global unicast is for a public communication purpose. Private ranges are given for a private LAN communication within the LAN or with the private network communication purpose. The global unicast used for a global wide communication means public communication. Link local within your segmented. Okay. Link local is within the segment. So every PC automatic generated link local IP address is there. Definitely it is there. Can you see? When I checking an IP address, you can also find their link local IPv6 address. This is not this one. This is link local IPv6 address. For each adapter, if it is IPv6 is enabled, it will generate. See the FE80 colon FE80 colon means it is link local IPv6 address. It is automatically generated by our system only. It is used to communicate within the LAN network, within your own segmented network only. It cannot be cross router. We cannot use outside of router network outside of your gateway network. You can't communicate using link locally within the network only. Intranet only it will work. Okay. Intranet or maybe within the segmented network it will work. But private IP address can be communicate over the router, means one private to another private communication. Multicasting, yes, a multicast is like a group messaging, like in certain services use the multicast method. Loopback or local host. Loopback or a local host. So colon 1. In IPv4 we use 0.0.0.0. Sorry. One, yeah, that is here in IPv6 it's a colon only. In a loopback or local host, we use 127.0.0.1. In IPv4, it is 127.0.0.1. In IPv6, it is colon 1. Okay. These are the some basic difference between IPv4 and IPv6 and about IPv4 also. So tomorrow we'll see what in these ranges, what we can use it, what we can't able to use it, what are these reserved kind of stuff, and how to check the it's a network and host portions, use of subnet mask, okay, and then private IP addresses, public IP addresses, okay, and NAT and PAT technologies, how to assign IP address, already I told. Okay. Remaining things we'll see tomorrow. Okay, that's it for today. Any doubts, questions?